We just hit 1,000 subscribers a little over a week ago, so this video is for all of you, and if you're not subscribed yet, there's still time before this video starts. So everyone that subscribes to this channel is obviously just a super cool person in general, you know, really affable, has a lot of friends, really funny, generally just really good looking, philanthropic, all those sort of good things, just an overall amazing person. And on this channel we do a lot of computer science stuff, so how do I combine my amazing subscribers with computer science stuff? If you want to see the actual implementation of this, plus a little heartfelt message, stick to the end. If only there was a way for a computer to know if someone was a subscriber within a matter of seconds just by looking at them. So in order to do this, I had to focus on a single word, because you know, with machine learning, having multiple words, things get a little bit too spicy. So I picked the word cool, because obviously my subscribers are just generally really cool people. Now, when you think of what makes someone cool, what do you think of? You know, just take a second. I say the word cool, what do you think of? Maybe someone who's driving a really fast car, maybe someone with a lot of popularity or money, and maybe that's true, but trying to analyze that I think would melt my computer. But for me personally, I think of someone in really cool shades. You are seeing in real time my computer determining if I am a subscriber or not. So right now, it clearly says I'm not, but if I raise my coolness factor by tenfold, it's obviously apparent that I must be a subscriber.
That is one cool subscriber.
So here we are. You can hook this bad boy up to doorbell cams, street cams, and the model can even be exported to cell phones. I know it's not much, guys, but honestly, this took me a long time to do. I'm gonna go over all the code and the actual implementation of the machine learning stuff and how I built this in a second, but in all seriousness, I just want to thank each and every one of you for your support. Honestly, when I read some of the nice comments that you guys leave on my videos, no matter how bad of a day I'm having, it honestly just makes me feel a lot better. I started this channel about 1.5 years ago, and I documented a lot of different parts of my life, like studying abroad, graduating college, and starting my first full-time job. And I can look at my old videos and see how I've changed, and I just want to thank each and every one of you for that. And I hope I was able to give you guys some good advice occasionally, and potentially a different perspective on things. It's been an honor to share parts of my life with all of you, and cheers to many more. Also, for the people who keep saying I look like Harry Potter, I know, I get it a lot, but this is for you. A little subscriber special. Hermione? Alright, now for the implementation. So to do this, we are going to use a couple different technologies. Like in my last machine learning video, I'm using Microsoft's custom vision tool, but instead of image classification, we are going to go with object detection. Now, unfortunately, we don't have a ton of classes, just 2 actually, either a subscriber or not a subscriber. And the model will be trained specifically on my face. In order to get enough training data fast enough, I used OBS to record myself both with and without sunglasses, then used a VLC media player to extract the frames from those recordings. After training the model, we can see it's pretty accurate with its object detection, and when setting up the Azure resources for this model, I designated that the model should be compact, which means that it can be exported to TensorFlow and ultimately Opencv. I found some code that was face detection with Opencv and a cascade classifier, but since we are using our own pre-trained model with TensorFlow, it's not as simple as just swapping the models. Fortunately, Custom Vision has some pretty good documentation about how to actually use this exported model, combined with some other resources I found. You can also find all the resources I used in the description if you want to check them out for yourself. Now, in my initial tests, the frame rate was kind of terrible, so I looked for some optimizations, and I found that if you do the object detection on a separate thread, you get slightly better performance, but only marginally. Then, since the model is running on my CPU, I decided to install NVIDIA's CUDA, which would allow it to be run on my graphics card, which has significantly better performance for machine learning things than my CPU. After waiting and waiting, I found that it didn't even make that much of a difference. Eventually, what I chalked it up to was that when I first tried the face recognition with Opencv with a tutorial, I was using a hair cascade classifier, which is very fast. In comparison, my custom vision model is relatively slower, so this decreased frame rate was simply due, at least I think it is, due to the speed at which the model could predict a given frame. So what you saw earlier in the video was I actually sped up that clip in post so that it would appear more fluid and less clunky, just for a better viewing experience. Alternatively, I could have tried to train my own Cascade model, but I wasn't too familiar with it, and I honestly wanted to just give custom vision a chance. But maybe in the future if I want to try to get some increased performance. So briefly going through my code, and just as a side note, I didn't write this all perfectly from my own mind. I did use a lot of resources, so I just want to make sure I give credit where credit is due. We have two classes, TF Object Detection, which actually handles the passing of the image to the pre-trained TensorFlow model, and I got this from Microsoft's documentation, and then the file video stream, which handles starting the processing on a new thread, which I found when I was looking on how to increase the frame rate. So down here we have an infinite loop that basically starts the camera with Opencv. We pass the image to our preloaded model, which returns a dictionary of dictionaries, so looping through each item to graph the associated tag name and set the color to either green or red. Then this computation here will get the coordinates for the box and then add those to the frame, and lastly we just tell Opencv to display that frame. Thank you guys so much for watching this video, and again thank you so much for the support and reaching 1,000 subscribers. That's a huge milestone. A lot more videos to come. If you have any suggestions, feel free to leave them in the comments. You can always count on bad British accents from your boy over here, and stay cool. See you in the next one. Bye bye.